Let's walk through a key for 6-5 over determinants and Kramers Rule. After all the hard work you've done understanding matrices to this point, this one's kind of fun. There's not a lot of new ways to do things here. We're just putting together some things you've known for a while to use in a new way. We are learning how to solve determinants in order to give us another way of solving systems. We'll use determinants to solve a system using matrices. So first we have to find out how to solve, how to find the determinant. The determinant is just the name for a real number that is associated with a square matrix. Now notice that we only find determinants of square matrices. So if you don't have a 2x2 or a 3x3, etc., you're not going to find a determinant. We are just going to do determinants of 2x2 and 3x3 matrices. You could keep going and find determinants of bigger square matrices. It's just more work, more layers. If you're going to use determinants to solve a system and you get that the determinant is 0, that main determinant is 0, that means that the system is either going to be inconsistent and there is no solution, or it's going to be dependent and there's an infinite number of solutions. If this happens, you can't use Kramers Rule. You can't use determinants to solve. You have to go another way. You could set it up and do row operations, or you could just use addition or substitution to solve. But if you get to the point where d equals 0, you know you don't have a single solution, your system is either inconsistent or dependent, and to figure out which one it is, you have to use a different method. Okay, so for a 2x2 matrix, we're going to find the determinant by finding the difference of the cross products. Now, finding the difference of the cross products means that we are going to subtract the cross products. It's not hard. You just always have to make sure you start in the right place. Where I have matrix A, and we have 4 elements in matrix A, this row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. I use looks like absolute value bars to symbolize that I'm going to get the determinant. See the difference between the matrix symbol, which is kind of a box squared off, and then when I'm finding the determinant, I just use absolute value bars. You always start here. This is where you start when you're finding the determinant. You get this first cross product by multiplying top left by bottom right, and that's what you start with. Then you find the other cross product and subtract that from the first. And that's it. That's how you find the determinant. So let's do a few of those to practice. If we find the determinant of B, that means, I wrote these all in matrix symbols instead of writing it with my determinant symbol. So let's go ahead and rewrite it and say determinant. And then we've got those 4 elements. If I'm finding the determinant, I'm going to start in my upper left to find that first cross product. 3 times 5 is 15. And then I subtract, I find the difference of the other cross product. 4 times 1 is 4. So I do 3 times 5, always start upper left. 3 times 5 is 15 minus 4 times 1. And that gives me a determinant value of 11. So the determinant of B is 11. I could say the determinant of B is 11. Okay, let's do these others. C, I'm going to go ahead and rewrite and put it in the correct notation. Got a 2x2 matrix, so we know we have a determinant. I'm going to show, dear, I nearly knocked my support down. I'm going to show, always start top left. So I find this first product, 4 times negative 3 is a negative 12 minus. I'm always finding the difference, so I write down that minus. 4 times negative 3 is negative 12 minus, and then 2 times negative 6 is also negative 12. So I am subtracting a negative 12. When I subtract a negative, I need to think about adding the opposite. So this becomes negative 12 plus 12, which is 0. So here I have a determinant of 0. Remember, if I were using these to solve the system, I would have to stop here. Because the determinant of C is 0, that means that if this were part of a solution to a system, if it were, then my system would be either inconsistent or dependent. So let's make a note here. If we were solving a system, if we were, and we don't have a system, we don't have any constants, so we just have a 2 by 2, it's not augmented. But if we were solving a system and we got this determinant of C is 0, then the system is either inconsistent or dependent. I either have no solution or infinitely many solutions, and I have to use another method to figure out which one it is. Okay, let's go again. Let's do the next one. I'm going to go ahead and rewrite it using my determinant bars. 8, 3, negative 4, 2. When I start finding my cross products, I always go start in the upper left. So 8 times 2 is 16 minus, and then I do bottom left back up right. I have negative 4 times 3. So minus negative 12, 36, 16, good grief, 16 minus negative 12 becomes 16 plus 12, or 28. My determinant of D, matrix D, is 28. You go ahead and do these next two. Notice that where my negatives were on this one, when I do my first cross product, I get negative 12, negative 2 times 6, minus, I'm subtracting, always finding the difference. My second cross product is a positive 12, because a negative times a negative is a positive. So negative 12 minus 12 is a negative 24. And then my last determinant, all the elements are positive for this one. So I don't have to worry as much about where I would have negatives show up. Always start in that upper left position. So I have 5 times 4 is 20 minus, and then 4 times 9 is 36. And 20 minus 36 is a negative 16. So my determinant could be positive, or it could be negative, or it could be 0. All right, let's look at Kramers Rule. Kramers Rule uses determinants to solve the system of equations. Remember that when I'm solving a 2-variable system, 2 equations, 2 variables, I'm looking for an ordered pair as my solution set, right? Well, when I use Kramers Rule, that ordered pair is represented by determinants. I have 3 different determinants that I'm going to find. The main determinant D, D sub x, and D sub y. So that when I put those together to give me my x and y coordinates, I have d sub x over d, d sub y over d. So that d sub x over d is my x coordinate, and d sub y over d is my y coordinate. Okay, so let's look at the system. I just have general terms here. So this tells you how we find those determinants. My coefficients on the x variables are a coefficients. My coefficients on the y variables are b, and my constants are c's. I have a first equation, so they're all sub 1, and I have a second equation that's all sub 2. To find the main determinant, I take the coefficients on the x variable and the coefficients on the y variable, and I find that determinant. That is D. My coefficients on x and my coefficients on y. So that's my coefficients on x, and that's my coefficients on y. Now I need d sub x and d sub y. To find d sub x, I'm taking out the x coefficients, d sub x. I replace the x coefficients with my constants. And then I leave the y coefficients where they are. To find d sub y, I take out the y coefficients and I replace those with my constants. And I leave the x coordinates or coefficients where they are. So if I want to think of it as x, y, and constants, my main determinant, x column, y column. For d sub x, I replace the x column with the constants. For d sub y, I replace the y column with the constants. Let's do one. It's really not hard. It's pretty simple. So we have our system of equations, two variable system, two linear equations, and two variables. I have x coefficients, I have y coefficients, and then I have that constants column. I'm going to need to find three different determinants. I'm going to have to find d, I'm going to have to find d sub x, and I'm going to have to find d sub y. Now when I set these up, I use different combinations. For my main determinant d, I use the x and y coordinates, coefficients, sorry, x and y coefficients. So this x column is 12, 2. The y column is 3, negative 3. To find d sub x, the second determinant, I'm going to replace the x. Well, the x is the first column, so I just go ahead and write down my y coefficients. And I replace the x coefficients with my constants, 15, 13 in this case. For the last determinant, d sub y, I'm taking out the y coordinates, or coefficients, good grief. So I leave my x's, I put my x's back, 12 and 2. And then I'm taking out the y column and I'm replacing it with the constants. My constants are 15, 13. All right, we have all three of our determinants set up. Let's solve them. So determinant of d, the determinant d, the main determinant, I start here and I do cross products. So 12 times negative 3 is negative 36. And then I have 2 times 3, so minus. Negative 36 minus 2 times 3 is 6. D is negative 42. It's not 0, so we know we're going to have a single solution to our system and we can keep going. Now let's do d sub x. Start in the same place, find cross products. 15 times negative 3 is negative 45 minus, and then I have 13 times 3, which is 39. Those are both negative. Negative 45 and a negative 39 gets me to a negative 84. So d sub x equals a negative 84. And I do my third and final determinant. Get up here where I can write. D sub y. So I do my first cross product. 12 times 13 comes out to be 156. 12 times 13 is 156 minus, and then 2 times 15 is 30. So d sub y is a positive 126. Okay, now I need to put these together to give me the solution to the system. The solution xy is d sub x over d sub y over d for the x and y coordinates. Well, d sub x over d, and then d sub y over d, and I need to simplify. Negative 84 divided by negative 42 is a positive 2. Positive 26 divided by a negative 42 is a negative 3, and that's my solution. Now, I always get the question, couldn't I have just added or substituted to solve the system? Absolutely, yes, you could. We're learning multiple paths to get to the same result. However, on the exam and in the homework, it's going to ask you for these particular pieces. So it's going to want to know what is d sub x, what is d sub y, what is d, before you simplify to get the solution. And you can't get these values without applying Kramers Rule. Let's do another example or two. Okay, so we have a system. We need to set up our three determinants and figure out whether or not we have a solution, a single solution, and can finish solving. In fact, it's smarter just to go ahead and check D before you do d sub x and d sub y to make sure that you're going to be able to use Kramers rule to solve. So to find my main determinant, I use the x and y coefficients. So that's going to be 5, 3, 4, negative 6. Be careful to include those negatives where they show up in your problem. Find your cross products. 5, negative 6 is a negative 30 minus, because you're using the difference, 3 times 4 is 12. And a negative 30 minus 12 is a negative 42. That's not 0, so we know we do have a single solution to our system, and we can continue with Kramers rule. So now we need to find d sub x and d sub y. To find d sub x, we replace the x column with the coefficients, with the constants. X column with the constants, so that's 12 and 24 in the x column. To find d sub y, we replace the y column with those constants, 12 and 24. So to solve d sub x, we took out the x coefficients and replaced them with the constants. We keep the y coefficients. Find your cross product. 12 times 6 is 72 minus 24 times 4. Well, 24 times 4 is going to be 6, carry the 1, 96. 96 and 172, no. What did I do wrong here? Negative 6 is a negative 72. 12 and negative 6 is a negative 72. See what I said about being careful of those negatives? A negative 72 and a negative 96 gives me a negative 168. And then to find d sub y, I replace the y column with the constants, so I still have those x coefficients. 5 times 24 is 120. And then minus 3 times 12 is 36. And 120 minus 36 is a positive 84. All right, the solution to this system, I have d sub x over d and d sub y over d. D sub x is negative 168 over negative 42. And then d sub y is 84 over negative 42. Where my signs are the same, I have a positive. Negative 168 divided by negative 42 is positive 4. And this one is going to be a negative 2. And that's the solution to that system. We have 2 more examples here. And then we move on to expansion of 3 by 3 matrices. Okay, so let's look at the next one. I always like to have my space delineated, so there we go. All right, I missed a sign there. Hopefully I'll have that fixed before you guys get this printed. But that should be 2x minus 4y. 2x minus 4y equals 8. Okay, so that first equation, 2x minus 4y equals 8. Second equation is negative x plus 2y equals 6. I'm going to find d to make sure I can solve this system using Kramers rule. I use my x and y coefficients. So I have 2, negative 1, negative 4, 2. When I find this determinant, 2 times 2 is 4 minus negative 1 times negative 4 is a positive 4. And 4 minus 4 is 0. That means that my system is either independent. No. This means that my system is either inconsistent and there's no solution, or dependent and there's infinitely many solutions, and I can't use Kramers rule to figure out which one it is. I'm going to have to do something else to figure out what it is. Well, I think it's going to be easier to do addition rather than substitution. If I multiply the second equation times a 2, my x variables would cancel out, because that would be 2x and that next one would be negative 2x. So let's do that. My first equation is 2x minus 4y equals 8. My second equation, if I multiply it by a 2, would be negative 2x plus 4y equals 2 times 6 is 12, yeah. So let's add those two. You see, I just multiplied the second equation by a constant. All right, do addition. I set it up so that my first term, my x's add to 0. Well, look at that. My y's also add to 0. So what I get is 0 equals 20. And 0 equals 20 is not true. When I get something that is not true, if I've done everything correctly, I have a system with no solution, which I can symbolize using the empty set. Let's do this next one. See if we can solve it using determinants and Kramers rule. I use my x and y coefficients. The first equation is the same as the one above. The second equation is a little different because I have a different constant here. So let's see what happens. Oh, you know what? The first equation is the x's and y's are the same here as they were up there. So when I set out this determinant again, I'm going to still get 0 because I've got 2, -1 in the first column, -4, 2 in the second column. That gives me a determinant of 0, which means that my system is either inconsistent or dependent, and I have to do something else to figure it out. I can do the same thing. I can still multiply this by 2. It's going to give me a different answer here because I changed this constant was a 6, now it's a -4. So let's do the addition. We're not changing the first equation. The second equation is -2x plus 4y equals -8. Now when I add these two equations together, I still get 0 on the left, but this time I also get 0 on the right. 0 equals 0 is true. It's always true. And if I get that always true statement, it means that I have a dependent system with infinitely many solutions. How do I write that I have infinitely many solutions? Well, I say it's going to be any ordered pair xy such that it satisfies one of the two equations in the system. And I can write either equation. I don't have to do both. But that is my solution set that shows me I have infinitely many solutions. Okay, so that's how we work with Kramers rule to solve systems. Let's talk about finding determinants of 3 by 3 matrices. Now, like I said, you can go bigger, but we're going to stop at 3 by 3 matrices because the layers just get more complex, and I just chose we're going to stop here. Expansion by minors is how we find determinants for a 3 by 3 matrix. Now, it's not tricky, okay? The pattern is that you use the first column. So you're going to use these A values, A sub 1 minus A sub 2 plus A sub 3. So A sub 1 times a minor minus A sub 2. That minus there for the second term is important. Times the minor plus A sub 3 times the minor. Now, when I say the minor, I mean I am reducing my 3 by 3 matrix to a series of smaller 2 by 2 matrices. If I'm going to find this first minor, I'm covering up the row and column that this element is in. So A sub 1 is in first row, first column. So that's what I cover up. And what is left are the 4 values in that minor. Let's just do one. I think it's easier to do that way. So first identify that first column. We've got 2, 5, and 4. Remember that we do minus on the middle one. That sign changes on the middle one. So we're going to have 2 times a determinant minus 5 times a determinant plus 4 times a determinant. 2 minor, 5 minor, 4 minor, and then we change the sign on that middle term. Okay, now what goes inside? Well, what goes inside are the 4 values that are left when I cover up what is being used. I'm looking for a smaller pen than what I have. I don't think I have anything smaller. Okay, I found a way to make do. So if I'm using that 2, I'm going to cover up the row and the column the 2 is in. And those 4 values that are left are what I fill in for that determinant. Okay? Oh, it's not going to work on the next one. Now I move down to 5. I want to cover up the row and the column that 5 is in. See, I cover up the row and the column the 5 is in. And what I'm left with is 1731. So I covered up the row the 5 is in and the column the 5 is in. And I'm left with 1731 as that minor. Okay, now I'm to 4. So I cover up the row the 4 is in as well as the column the 4 is in. And I'm left with 1760. So whichever of my elements I'm using, I cover up its row and column. It's always going to be this first column. So I'm just figuring out, am I covering up row 1, row 2, or row 3? Okay, let's find these determinants. So I have 2 times difference of the cross products. Well, 6 times 1 is 6 minus 3 times 0 is 0. And then I have, so this is going to be 2 times 6, right? Then I move to the next term. I have minus 5 times, well, 1 times 1 is 1, minus 3 times 7 is 21. 1 minus 21 is a negative 20. So I have minus 5 times a negative 20. And then this third one is plus 4 times its determinant. 1 times 0 is 0, minus 6 times 7 is 42, which gives me plus 4 times a negative 42. All right, 2 times 6 is 12. 5 and negative 20 is a positive 100. Positive 4 and a negative 42 is a negative 168. 12 plus 100 minus 168 comes out to be a negative 56. And that's the determinant of this matrix. Let's go again. So remember, you're going to set out 3 different terms. You're going to start by using the values in the first column. And you're going to change the sign on the middle one, because that would be minus. In this case, it's minus a negative 9, so it changes to plus 9. So I have 4 times some determinant plus 9, because it was minus a negative 9. Minus a negative 9 becomes plus 9 times its determinant. And then I keep this sign like it is. So it's keep, change, keep. That would be minus 3 times its determinant. Well, how do we fill in those determinant minor boxes? We use what is not covered up. We're going to be covering up that first column every time. When I'm using 4, 4 is in the first row, so I don't use the values in that first row. Instead of the values in that first row, I'm using rows 2 and 3. So for this one, it is 3, 8, 4, 1. 3, 8, 4, 1. Then where I'm using this negative 9 minus the negative 9, I'm not using the second row. So I'm never using the first column. I'm not using the second row. So what I have left is going across 1, 0, 8, 1. 1, 0, 8, 1. And then finally, this negative 3 comes from the third row. So I'm going to cover up that third row as well as the first column, just like always. So going across again, I would have 1, 0, 3, 4 to fill in my minor determinant. Okay, next step. Find each of these 3 determinants. So I have 4 times something. What's my something? Well, 3 times 1 is 3 minus 8 times 4 is 32. What about the next one? Well, this is going to be plus 9 times something. I've got 1 times 1 is 1 minus anything times 0 is 0. And then I've got minus 3 times something. 1 times 4 is 4, minus, and again I've got a 0 there because 3 times 0 is 0. All right, 4 times, well, 3 minus 32 is a negative 29. 9 times 1 is just 9. And minus 3 times 4 is going to give me a negative 12. All right, this is a negative. 4 times 9 is 36. Carry my 3. 4 times 2 is 8, plus that 3 is 11. Negative 116 plus 9 minus 12. Negative 116 and negative 12 is a negative 128 plus 9. Negative 128 plus 9 is a negative 119 as my determinant. All right, I want to challenge you guys. You set this one up. Pause the video, set this one up, figure out the determinant, and then come back to see if you got it right. All right, guys, here's what I got. Go through and check my arithmetic. Make sure that you set your problem up like I did mine. You have 3 minus 2 plus 2 from the first column. Then check to make sure you use the right 4 values in each of the minors. Then when you do your cross products, you're always starting upper left. Anything times 0 is 0. And you're finding the difference. And that's it. I'm opting for us not to do determinant Kramers Rule with the 3x3 system. So that's, you just need to worry about the 2x2s and to make sure you know that process to find determinant using expansion by minors.